Hey everyone, so this is your friendly neighborhood math teacher, Mr. Bennett. Going to go through lesson 1.3 today. So as you can see right there, our objectives are how to design a statistical study and how to distinguish between an observational study and an experiment, how to collect data by using a survey or a simulation, how to design an experiment, and how to create a sample using random sampling, simple random sampling, stratified sampling, cluster sampling, and systematic sampling, and how to identify a biased sample. So as you can see, there's lots of different types of sampling we can do here, and we'll kind of walk through those towards the end. But first, the design of a statistical study. The goal of every statistical study is to collect data and then use that data to make a decision. Any decision you make using the results of a statistical study is only as good as the process used to obtain the data. Okay, if your process isn't good, we can't trust that the data we collected was valid. So you need to be familiar with how to design a statistical study. And there are some guidelines down below. It says identify the variables of interest, also known as the focus, and the population of the study. Develop a detailed plan for collecting data. If you use a sample, make sure the sample is representative of the population. C, collect the data. Then describe the data using descriptive statistics techniques. Interpret the data and make decisions about the population using inferential statistics. And F, identify any possible errors. And so a statistical study can usually be categorized as an observational study or an experiment. So first, an observational study is exactly what it sounds like. It is where the researcher observes and then measures characteristics of interest of part of a population, right? So it's literally you are just observing. You are not doing anything to anybody. You're just kind of standing back, collecting what's happening in real time. So the example it gives here is researchers measured the amount of time people spent doing various activities, such as paid work, childcare, and socializing. So again, they didn't tell people, hey, you need to go to work, hey, you need to watch your kids, you need to go out and go party, you need to go exercise. They just simply said, hey, I'm just going to watch and see what you guys are already doing and make a note of it. And so therefore it is observational. Okay, you're observing what's happening. There's a slightly different variation of that, which is an experiment, right? And so typically, I don't know about you, but for me, an experiment, right, I typically think of science, right? Like, oh, let me take all these chemicals and shove them together and see what happens. And so in stats, an experiment is kind of along those same lines, right? An experiment is where I do something, right? Like pouring in the chemicals and seeing what happens. I'm going to do something. It's called applying a treatment. A treatment is applied. And we're going to see what happens. Okay, we're going to apply that treatment to a part of the population known as a treatment group. And then we're going to observe the responses. Okay, so we are actually affecting what the people are doing or what the plants are doing or whatever it is that we're trying to observe. So it says another part of the population may be used as a control group in which no treatment is applied. Okay, we are the ones controlling them. We are not giving them a treatment. And it says the subjects in both groups are called experimental units. Okay, but a control group is there's one part of the sample that I'm taking. They get the treatment, right? They get to, take the Gatorade that I'm trying to come up with, right? This group gets to take the Gatorade. This other group does not get to take the Gatorade. The group that does not is called a control group. In many cases, subjects in the control group are given a placebo. This is a key important word you need to know. It'll come back later in the lesson. But the placebo is just basically a fake treatment. Okay, so in the example I just gave you, right, I'm creating this new type of Gatorade, Powerade type of drink. And so part of the group, one group that I selected gets to taste the Gatorade, gets to drink it, see how it affects them. The other group gets to take this other liquid, and it is not the new Gatorade. Okay, it's just some liquid. So they're thinking they might be taking the Gatorade, but they're not. Okay, it's just pure fake. It might just be water. But it's made to look like the real treatment. Okay, that is important, is I kind of want to make sure that they don't know kind of what it is they're taking, so that they don't know that they're not just taking some random just water or whatever else. So the example it gives here, an experiment was performed in which overweight subjects were given the artificial sweetener sucralose to drink while a control group just drank water. So after performing a glucose test, researchers concluded that sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. Okay, so again, one of them were given the sweetener and a control group just drank water. Right? One group gets the treatment, the other group gets basically nothing, right? But they don't know that. So it says, asks us to determine whether each study is an observational study or an experiment. So number 1 says, researchers study the effect of vitamin D3 supplementation among patients with antibody deficiency for frequent respiratory tract infections. You don't really know what those are? That's okay. 70 patients receive 4,000 IU, which are just international units. It's just a unit of measurement of vitamin D3 daily for a year. So 70 people get the vitamin D3. Another group of 70 patients receive a placebo daily for 1 year. So one group receives vitamin D, and another group receive a placebo. Okay, when that happens, we are running an experiment. Right, we're giving a treatment to a group, and the other treatment is getting nothing. They're getting that placebo, right? There's that keyword, placebo. Question 2 says, researchers conduct a study to determine how confident Americans are in the economy. Researchers call 3,040 U.S. adults and ask them to rate current U.S. economic conditions and whether the economy is getting better or worse. So again, we have to look, did the researchers do anything to the people that they contacted, that they're collecting data from? In this case, no, right? All they did was call and ask them to rate, right? They did not have them do anything. They just said, hey, what are your opinions? What are your thoughts? Therefore, this is observational. Okay, I am just simply observing what people already do and think. Now, data collection. There's several different ways to collect data. Often the focus of the study will dictate the best way to collect the data for that study. And here's a brief summary of 2 different methods. So one is simulation. It uses a mathematical or physical model to reproduce the conditions of a situation or process. Often involves the use of computers, allows you to study situations that are impractical or even maybe dangerous to create in real life, and often save time and money. So the example they give here is, for instance, automobile manufacturers, car manufacturers use simulations with dummies, right? Simulations with dummies to study the effect of crashes on humans, right? They don't take actual humans, put them in the crash tests, and run the car into a wall, right? They use the little dummies that are made to recreate a fully sized human, and they use those to see what happens, okay? Another example of this is, let's say I wanted to roll a bunch of dice, right? I'm doing some kind of scenario where I need to calculate, how many number 3s that I roll if I roll 100 dice. And so I could sit here and actually take a physical dice and roll it 100 times. That's going to be a lot of work. So instead, what I might do is go to Google and Google a dice roller, right? And just click on 100 and click go, and it'll give me 100 dice rolls in a second. Okay, so again, that's that idea of using the computers. It's kind of impractical and saves time, right? I don't need to sit here and roll dice all day long when I have a simulation that can do it for me. Another way to collect data is through a survey. So we first had simulation, now we have surveys. And so a survey is an investigation of one or more characteristics of a population, usually carried out on people by asking them questions. Okay, we can do this by interview, internet, phone, mail. And in designing a survey, it is important to word the questions carefully so that they do not lead to biased results, which are ultimately not representative of the population. Okay, so an example of that importance, right? How do we word the questions that we're going to give to people? I could ask people, do you support building a football stadium at Reedley College? Because Reedley College doesn't have its own, it uses Reedley High Schools. But if I word that slightly differently, do you support raising your tuition to build a football stadium at Reedley College? Now we're starting to get in that, I don't really know, right? I might be changing the way people respond just based off of the way we've asked the question. Okay, so we have to be careful in terms of what it is we're looking for and how can I get real, honest responses from people. So experimental design. To produce meaningful, unbiased results, experiments should be carefully designed and executed. There are three key elements, which are control, randomization, and replication. Okay, I need to make sure that I have control over things and a control group. There needs to be some level of randomization to my process so that I get a true group a group representing the population as a whole. And then replication, is this something that I can do over and over again to kind of verify that my results are in fact valid? Okay, or is this something that I'm really only going to be able to do once? So first, when we look at control, right, making sure that we have control over everything that's happening, the huge thing we want to look for is something called a confounding variable. Okay, confounding variables. This occurs when an experimenter cannot tell the difference between the effects of different factors on a variable, right? So I'm doing something in particular. I have this study. We're running this. They get a specific treatment, but I can't really tell, was it the treatment, right? Was it maybe the new medicine I gave them, or was it something else, right? Like let's say I'm doing a study and I give everyone a new version of ibuprofen. Okay, well, if I do that and they get better, was it the ibuprofen or was it the fact that they got more sleep than they usually do, right? Was it the sleep that affected it, or was it the fact that they took 2 weeks off of work, right? Like there's all these different factors that we have to think about. So another example of this is a coffee shop owner remodels her shop. At the same time, a nearby mall has its grand opening. If business at that coffee shop increases, right, they get a lot of business at the coffee shop, it cannot be determined whether it is because of that remodeling, right? Hey, everyone likes this new look and design and the layout of the couches and the chairs and tables. Or was it the fact that there was a new mall and there were just a bunch of people that go to the mall and therefore they're like, hey, while I'm there, I might as well get a coffee. Okay, so those two things, the remodel and the shopping mall, have been confounded. Okay, I can no longer tell what it was that actually got people in the door, and so I can't really do much with that information. I don't know if the remodel was actually effective. So you just have to be careful and think about those things when we design a study. Now, the placebo effect, so earlier we talked about a placebo, right? The placebo is just something that we give to people that is basically fake, right? It's made to look like the thing that we're trying to give them, but it means nothing. It's not going to do anything. And so the placebo effect occurs when a subject reacts favorably to a placebo, when in fact, all they've been given is a fake treatment. Right? So like, let's say I'm designing a new energy drink, right? The next, Red Bull or Monster or whatever it is. And so I give this group an energy drink and I give the other group a placebo. It's basically like coconut water, right? Just something basic. And people in the group with the coconut water tell me and they react and say, hey, like this new energy drink is great. Like I feel super energized and I have a lot of like my eyesight is getting better and my focus is good. and all this stuff where things that you might feel if you took an energy drink versus, but they didn't actually get an energy drink. Okay, they just had coconut water. And so that's called the placebo effect, right? Even though they just took a placebo, them thinking that they were getting something actually made them respond as if they did. And so an example of this, in a study on knee pain done at the Houston VA Medical Center, researchers divided 180 patients into 3 groups. 2 groups had surgery to remove damaged cartilage, while those in the third group had simulated surgery. So they basically kind of went through the surgery, but then didn't. And so after 2 years, an equal number of patients in each group reported that they felt better. So those who had the simulated surgery were said to be responding to what is called the placebo effect, right? They went into it, they thought that they were getting surgery, and the doctors basically didn't end up doing anything at all. And the people 2 years later are like, yeah, my knee feels great. Like, whatever you guys did, like, I really appreciate it. And in reality, nothing happened. Okay, but they thought it happened, and so that's why they can feel that way. So to help control or minimize this, what we want to do is use a technique called blinding. So blinding, right, just kind of like how it sounds, right, I'm covering your eyes, right? You cannot see. And so it's a technique where the subject does not know whether he or she is receiving the treatment or the placebo, right? If I'm giving that new energy drink to see if people respond, they don't know if they have the energy drink or plain coconut water. They're just getting a bottle of unmarked liquid. Okay, so they have no idea the subject, the person drinking it, is blind. Now, another aspect that we can then implement is something called double blind, which is where the subject and the experimenter both don't know if the subject is receiving the treatment or a placebo. So it's double blind because now there are 2 layers of people who don't know, who are blind. And so it's not only the subject and the experimenter. So you might be saying, like, how does that really work? Like, how can the experimenter not know? Well, typically it just means that there's a third party involved, right? Maybe another researcher or a friend who takes the bottle of energy drink and fills one of them with the energy drink, fills the other with regular coconut water, right, my placebo, and they are the ones filling the bottles. So I just get a bottle marked A and a bottle marked B, and I hand those to the subjects. I don't know which is which. The subject doesn't know which is which. And eventually, after I get the responses, my friend or the other researcher will say, okay, A was actually this, and B was actually the energy drink. Okay, so there's just that extra layer of the person providing it, the person giving it, also doesn't even know, which is a really good thing because then it just helps minimize the amount of bias we can have, right? Where, hey, maybe I really want to see what happens when my buddy, who I know drinks a lot of energy drinks, wants to take it, right? Or whatever other aspect I may know about the people taking the drinks. And so one of the challenges for experimenters is assigning subjects to group so that the groups have similar characteristics, such as age, height, weight, and so on. When treatment and control groups are similar, I'm in this paragraph here, experimenters can conclude that any differences between groups is due to that treatment, right? So basically, I want my groups to be as similar as possible. So if I want to see how this new energy drink affects people, I want both groups to have people that are kind of the same, right? A mix of guys, a mix of girls, maybe a mix of younger people, and some older people, right? I want both groups to have a wide variety of people. And so it's not just, the energy drink group happened to just be a bunch of young people, and the placebo happened to be a bunch of older people, right? So it doesn't really help me see what's happening because now I'm only getting results for young people. So in order to do that, we use randomization. Okay, so randomization is a process of randomly assigning subjects to different treatment groups. And a completely randomized design is where subjects are assigned to different treatment groups through that random selection. Okay, So sometimes it is necessary for the experimenter to use something we call blocks. And so a randomized block design is where they divide subjects with similar characteristics into blocks, and then within each block, randomly assign subjects to treatment groups. Okay, so they give an example here. An experimenter testing the effects of a new weight loss drink may first divide the subjects into age categories, which are these right here, right? 30 to 39, 40 to 49, and over 50. So first, they all get split into age categories. Then they get split into control and treatment. Okay, and they do so randomly. Okay, and we'll talk about how to do that here in a little bit, but that's the idea. Okay, is they first create blocks of some type of characteristic. It can be age, it can be gender, it could be, location, depending on what we're doing, whatever it is. Now, another type of design, so we had randomized blocks. We can also do what we call a matched pairs design, where subjects are paired up according to a similarity. One subject in each pair is randomly selected to receive a treatment, while the other receives a different treatment. They give an example right here. I'll be honest, I don't care much for this particular example. So the one I've used in the past for matched pairs design is like, let's say I want to see how something affects students based on their GPA, right? So probably how I would do this is I would want to keep students who are similar, right? Like my higher achieving students together and my more middle or lower students together. And so what I might do, I say, okay, I have the student who's a 4.0, I've got a student who's a 3.9, maybe a 3.9, maybe a 3.8, maybe a 3.6, maybe a 3.6, and so on. And so what I'm going to do is I'm going to match these pairs together so that ultimately I have kind of a nice split of people, right? Because if I did true randomness here, I could end up with all the top people in one group, right? Chances are pretty unlikely, but it could happen. If I do it this way, there is no way that that can happen, okay? This is automatically my treatment, this is my control, this is my control, this is my treatment, this is my control, this is my treatment, right? There's no way. So I'm going to get a variety of different types of people that are in my treatment rather than just, the top 4 people happen to be in this group. Okay, so it almost forces a little bit more kind of a spread here in this case. The other thing we want to consider when we are doing an experiment is our sample size. Okay, sample size is just the number of subjects in a study and is very important. Okay, we want to make sure we have a large sample size. And then on top of that, we want to, again, we've mentioned this earlier, this idea of replication. Okay, can I repeat an experiment using a large group? Okay, so it's maybe fine if I did it for a smaller group, but could I replicate this with a bigger group? And could I do it again if I needed to? Okay, could I run this experiment multiple times to get see if I get different results or see if I get the same or similar results each time? So the example it gives here says to test a vaccine against a strain of influenza, the flu, 10,000 people are given the vaccine and another 10,000 are given a placebo. Because of the sample size, because I had so many people, right, 10,000 is kind of a lot of people, because I have a large sample size, the effectiveness of this vaccine would be most likely to be observed. Okay, so we can actually say because I got enough people, I can measure if the vaccine was effective or not. So now it wants us to identify a potential problem with the given experimental design and suggest a way to improve it. So number 3 says a company wants to test the effectiveness of a new gum developed to help people quit smoking. The company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 using the new gum have quit smoking. So hopefully, kind of while you were reading this, one of the most obvious things that you saw was that we're looking at 10 adults. Okay, there are 5 who get the new gum and 5 who are given the placebo. Okay, that is not very many people, right? If I'm only testing this on 5 people, it could be very effective for them, but is a group of 5 people really representative of all smokers, like all the people who smoke? Probably not. And so the biggest issue here is that our sample size is too small. Okay, we need more people. So how small is too small? Kind of depends on what you're doing. And there is kind of an equation, a formula we'll look at later about determining if a sample is too small or not. But for now, right, we would just suggest using more people, more specifically more smokers, right? Maybe 1,000, right? If we could get 1,000, that'd be probably pretty good. Okay, at least a good start. Now for question 4, it says a company wants to test the effectiveness of a new gum developed to help people quit smoking. The company identifies 1,000 adults, okay, that's good, they have a large sample now, who are heavy smokers. The subjects are divided into blocks according to gender. So I'm going to have one block of people who are males and another block who are females. Okay, we start with 1,000 and those get split. I don't know if it's an even 500 and 500. I don't know if it's 600 and 400 or some random numbers in between. Thankfully for this, it doesn't really matter. The problem with this, so it says after 2 months, the female group has a significant number of subjects who have quit smoking. Again, I kind of mentioned just a moment ago that it doesn't really matter if it's an even 500 split. Really, the biggest issue here is that there's no control group, right? I know they're given the new gum, but I don't have anything to test that against, right? Was it the gum? Was it other things? And so by separating them into gender, that doesn't really do much for me. Okay, so we need a control group. And, one of the other kind of aspects of this is splitting into genders actually doesn't really help us here, because now gender could be confounding, right? Is there something about them being female that makes them more likely to do it, right? Was it the drug or was it that they were female? And so because of that, I can't actually say it was the gum. So there's a new variable that we've introduced here that doesn't, that gets in the way, right? That could be the reason, right? Maybe it just affects females more than males because of some chemical or hormone or whatever, okay? So what we would want to do instead of having split into genders, would just be randomize male and female together, right? Have 2 groups, right? A treatment group and a control group, where I have males and females in both, so that I don't know that's not really affecting anything in any meaningful way, okay? Because they're not separated. So some different sampling techniques. So first of all, the one you might have heard before is something called a census, which is when we count or take measure of an entire population, which again is a little bit tricky. It provides complete information, but it is often costly and difficult to perform, right? If I'm trying to find information about high school students, it'd be really hard to go through and survey every single high school student. So what I'm going to do instead is simply do a sample, okay? I'm going to take a part of a population, because that's much easier, much cheaper, cost-effective, time-effective for me to do. And so to collect unbiased data, A researcher must ensure that the sample is representative of the population. Appropriate sampling techniques must be used to ensure that inferences about populations are valid. Even with the best methods of sampling, a sampling error may occur, right? So even if we're super picky about how we do this, there could be a sampling error. Okay, our goal is to minimize it because it's not necessarily always going to go away, but it's the difference between the results of a sample and those of the actual population. Okay, so some ways that we can minimize this are by taking a random sample and a simple random sample. Okay, there's one key difference here. I know they seem like they're mostly the same, and for the most part, they are for most intents and purposes, but a random sample, the first box here, a random sample is a sample where every member of the population has an equal chance of being selected. So if I have all 1,000 people, every single person has a 1 in 1,000 chance to be selected. Okay. Now, a simple random sample, a little bit different, is a sample where every possible sample of a specific size has the same chance of being selected. Okay, so if I'm picking from, there's 8 people in the class. If I'm trying to pick a sample of 2, right, I could have 1 and 8. I could have, let's do this. 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8. I could have 2 and 3, 2 and 4, 2 and 5, 2 and 6, 2 and 7, and you get the picture. Okay, every single one of those are a possible sample. 1 and 2, 1 and 3, 1 and 4, 1 and 5, and so on. And so there are a certain number of possible outcomes that could happen. Okay, from that, does every single sample, each individual grouping, not just person, but each individual grouping, have the same chance of happening? Okay, if I picked 2 people, is the chances of getting a 1 and 2 the same as getting a 2 and 7? And are they the same as getting a 1 and 8? Okay, and so most of the time that will happen. You can have outcomes where that isn't particularly true, but for the most part it is. Okay, that's kind of the nice thing, is you don't always super have to worry about that, but that is technically what that means. Okay, that all the possible samples of a specific size have the same chance of being selected. And so when we do a random sample, we can use a random number generator, right? We can use some technology, which is nice. And so what we do is we assign a number to each member of the population. This is known as a frame. And then members of the population correspond to these numbers, become members of the sample, right? So for example, in our class, right, we have 8 people. Each of you would get a number. And then I roll a random number generator, and it tells me I'm going to use number 2, number 5, and number 3, right? So those 3 people become my sample. And 2, 5, and 3 just tell me who I'm picking. Okay. One of the ways we used to do this back in the day before computers was we take everybody's name, and you probably just saw this maybe when you're in elementary school or something. Right, we take everyone's name, put them on a slip of paper, and draw them from a hat. Okay. However, if we wanted to do that for like 1,000 people, that would be kind of difficult, right? Have 1,000 slips of paper and a giant hat, like it just wouldn't be practical. And so if it's large, we want to make a frame. Okay, we want to create this numbered list. Okay, a frame is a numbered list of all the individuals in the population. Okay, then we use technology to get some random numbers, and then those are the people that we're going to use. Okay, so the word frame is something you've probably maybe even done before or seen before. We just now have a term for it. Okay, a frame. This goes into a section about how to do this on a TI graphing calculator. You don't have TI graphing calculators, so you're not going to do this. It's actually very similar to this, but we are going to use the NumWorks calculator that we have in class. And the nice thing is it actually works very, very similar. So those directions, actually for the most part, especially this one, might actually kind of be useful. But I'm going to show you how to do this. Okay, so number 5 says use a calculator, TI graphing, but we're not going to select 5 students without replacement. So kind of a key word here is without replacement. What that means is, let's say these are names that we had on slips of paper and we threw them in a hat. Replacement means I would select a random number. Let's say I select McKinley, number 4. I tell McKinley he's on my list, and then I throw the number back into the hat. Okay, that would be with replacement. So without replacement just means once I select McKinley, he is out. His paper gets pulled out of the hat. I no longer worried about him. Now I draw another one, and now it's Colby. Okay, and then Colby's out once I draw her. Okay, that's what that means. So how are we going to do this? Okay, so first of all, we need our calculator. So I'm going to swipe over to here. On our calculator, you're going to turn it on, go to the home page. So if your calculator doesn't have this screen, you just hit the home button, right? If I'm in some random app, just hit the home button and we get back here and we're going to go into calculation. Okay, calculation is where we can do the basic like 5 times 2 and we get 10. Okay, you don't have to do that, but that's where we want to be. So in this screen, in the top right, you should see the delete button that says clear. To the left of that is this little toolbox button that says paste. It's this one right here that I've highlighted. And when you do that, we get a thing pop up on the screen that says toolbox. And we're going to go down, hit the arrow keys, until we get to probability. We'll hit OK. We get 3 options, combinatorics, distributions, and random. In this case, we want random. And there are several different options here. The first one we probably won't ever use. The second one, randint, is a random integer from A to B. So like if I just want a random number from 1 to 20, I could do that, type in 1, 20, and it would give me one single random number. So the problem is usually we want more than just one number. And so we want to use option, or the third option here, which is randint, no rep, which just stands for random integers, no repeats, no repetition. And so you'll see now it asks for 3 numbers, A, B, and N. And when we click OK, it gives us 3 spots, right? Because we have 2 commas. So the first number, second number, third number. So the first number is going to be the lowest number on our list, which in this case was 1, right? Our lowest number is 1. And our highest number is 12. So we're going to go from 1 to 12. So in our calculator, we're going to go from 1 to 12. And then our last number is how many random numbers do we want? And our directions in our notes said select 5 right here in the directions. Select 5. Okay, so we go from 1 to 12. As you can see here, it's almost the same in the other calculator. From 1 to 12, and then I want 5 of them. So 1 to 12, we want 5 numbers. Close my parentheses, and if you click OK or execute, there are 5 random numbers. And if you're doing this on your own, you probably got 5 different numbers. That's okay. I'm just going to use these for my example. So 10, 11, 4, 2, and 7. 10, 11, 4, 2, and 7. Those are my 5 people. So 10, 11, 4, 2, and 7. So we're using Kona, Kelsey, McKinley, Kelly, and Colby. Okay, those are the 5 people. So the calculator gave us these 5, which translates to using these 5 people. And that's that. And there is some more here. Okay, so if you have trouble, again, a reminder, The nice thing is if you're having to do this several times, when you hit the toolbox again, it should already be up so that it's still right where you left off. If you close out of that app, you'll have to go through that, which again is under probability. So you just scroll down to probability, scroll down to random, and then typically you want to use this third one, rand int no rep. Okay, from A to B, so that's from your lowest number to your highest number. And the last one, the third number, is how many numbers do you want it to give you? Okay, in this case, we did 5. And so a little bit more notes. To use stratified sampling, we can use stratified sampling, which is dividing a population into groups, also known as strata, and select a random sample from each group. So an example of this is a stratified sample of the number of people who live in Westridge County households. We could divide the households into socioeconomic levels and then randomly select households from each level. So again, right, we might say, okay, we have group 2 is our middle income, group 3 is our high income, and we separate all those houses, and then we roll a random generator, and these were the 3 houses we selected. Okay, so from that group, those are the 3 random ones. From group 3, we had 2 random ones. Okay, now another kind of variation of this is something called cluster sampling. And what we do then is we divide it into clusters, right? So groups this time refers to clusters. And then we're going to select all of the members in one or more, but not all of the clusters. So again, let's say we divide them into middle income and high income. And let's say we had group 1 was low income. And so I'm going to roll a random integer, no repeat, from 1 to 3, and I only want one number. And it spits out 2. And so in that case, I'm going to pick group 2, and I'm going to use all of those houses. Okay, it gives me the entire cluster, and then I use that entire cluster. So in this particular case, it kind of gives you another example, right? Let's say I take my county, and we divide those by zip codes, right? If you live in Fresno, Fresno has, 7 to 10 different, maybe, 5 to 7 different zip codes. They have several different zip codes. And so we're going to separate it by zip codes, and then again, roll a random number, and only use the people that are in this case, zone 1. Okay, so that's a cluster. So stratified is where we separate them into groups and then pull random individual ones from each group. Clusters are where we separate them into groups and then use one or a couple whole groups. Systematic sampling is where we choose a starting value at random and then choose every kth member of that population. Okay, so this is an example given below. This one's the one that's always kind of weird, and it's a little bit trickier to get. But in this Westridge County example, we assign a different number to each household. So each household is number 1, 2, 3, 4, 5, 6, 7, and so on. We randomly choose a starting number. So in this case, they randomly chose number 86. And then select every 100th household after that. So I'm basically skipping by 100 every time. So I'm going to skip from 86 up 100. And now we're using 186. Going to skip another 100, 286, skip another 100, 386, skip another 100, 486, skip another 100, and we get to 586, right? That's the idea, is so we start with a random number, and then we use the same jump every time, right? The same skip number every time. That's what this kth member is referring to. That's your skip number. So that's systematic sampling. There is a system that we're following. right? We're going by the same amount every time, or skipping by the same amount every time. And then lastly, or almost lastly, lastly, we have a convenience sample. Okay, this is not a great example, but we're choosing the members of the population that are easy to get. Okay, this one is not recommended. We could technically do it, but it's not recommended. So again, convenience, right? A convenience store is just a store that's on the corner, really easy to get to. It just means that we can just pick the people that are closest to us. So for example, if I wanted to do a study on the students at Sanger West, a convenience sample would be me just selecting my class, right? I don't have to go out anywhere else. I just pick the people in my class and we'll call it good. Okay. Another example of this would be if I want to get some data on whether people like Chipotle. So what am I going to do? I'm going to go stand outside of Chipotle and collect data from the people at Chipotle, right? That's convenient for me. You don't want to do that. This very, very often leads to bias. Okay, so you don't want to do that. But it technically is something you could do and you need to be able to recognize. So now we have a couple of examples to identify the sampling technique used. Number 6, you are doing a study to determine the opinion of students at your school regarding stem cell research. You divide the student population with respect to majors. So we're dividing it into groups of majors. So we're dividing into groups by major. And then randomly selecting. So randomly select and question some students in each major. So of our examples that we looked at on this page, the one where we group them and then select some in each major would be this one up here, okay, the stratified sampling. Stratified sampling. Okay, we created groups, in this case known as strata by major, and then selected a couple random kids in each major. And then lastly here, it says you are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling technique used. Number 7 says you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. This is known as a random sample. Actually, yeah, simple random sample is fine. Really, the key thing here is that it's a random sample. And then number 8, you just select students who happen to be in your biology class. That's a convenience sample, right? You didn't really do anything to make that easier, to make it more balanced. You just were like, well, I don't want to do any work. Let me just pick the people in my bio class. Okay. And oh man, that got cut off. That did get cut off. That's a bummer. Okay. I will, because there's a nice little graphic. I didn't realize it got cut off here. So I will make a note. I will post this in Canvas. It's just a really good kind of graphic between the disadvantages and advantages of observational versus experiments. To just kind of give you an idea of why we might do an experimental study versus just an observational study and vice versa. Okay, so I will take a screenshot of that and post that in Canvas. I apologize that I didn't realize that didn't come through, or if it did on yours, great. But either way, I'll still post it. And that's it. That is the end of chapter 1. That is our last section of notes. If you have questions on this, please let me know, but you do have an assignment for this. So please make sure you're working on that. And like I said, if you have questions, reach out. But as always, have a great rest of your day. Like the video, smash that subscribe button, chat it up in the comments below, all that fun YouTuber stuff. I don't know. I don't do YouTube, but I watch YouTube, but I ain't trying to make this a business. I'm just trying to help you guys out. So have a great rest of your day. I will see you guys later, and have a good one.